Well, we are going to continue our discussion of inverse trigonometric functions here. And you can see our first problem is to find the exact value of the cosine of the inverse sine of 1/2. And what makes this different than what we've done in the past is we're mixing trig functions. Previously, we'd have cosine of inverse cosine or sine of inverse sine, but never something like cosine and inverse sine together. So this very first problem is rather of the simpler type that we have to deal with or get to deal with. And I'll show you what I mean by looking at the first two examples. So what we're going to do is recognize, well, that the inverse sine is always an angle. The result of calculating an inverse sine or an inverse trig function is always an angle. So the inverse sine of 1/2 I could think of as the angle theta. And so that's what I've shown down here. I'm going to call theta this angle. Now, when I do that, let's keep in mind what that means. If theta is the inverse sine of 1/2, that means when we take the sine of theta, when we take the sine of that angle theta, we get the result of 1/2. And furthermore, you can see, okay, furthermore, the angle theta, that is the inverse sine, always has to be an angle between negative pi over 2 and pi over 2. It can include the endpoints or be in between. And so that means, of course, this is in the fourth or second quadrant, or first quadrant. Now, the sine of theta is 1/2, and so when I start thinking about what kind of angle that could be, well, the sine is a second coordinate along the unit circle, and so if I draw the angle that has a second coordinate of positive 1/2 that is in this range, then I conclude that that angle is pi over 6. And these are things, again, we're supposed to know at this point of the course, or we've got to be able to figure this out. So I'm determined theta is pi over 6. Now in the future, we're not going to be able to actually determine what theta is, but in this case, because it's not always one of our special angles, but in this case, we do know that theta is pi over 6. So our original problem to find the cosine of the inverse sine of 1/2 actually becomes find the cosine of theta, since theta is our new name for the inverse sine of 1/2. And that means what we need to do is calculate the cosine of pi over 6, since we know theta is pi over 6. And of course, the cosine of pi over 6 is the square root of 3 over 2. So this was pretty straightforward, if you will, because we could actually calculate what theta is. Theta was pi over 6. But in example 2, we won't be in that position. We won't be able to actually do the calculation and determine what pi over 6 is. What theta, the value of theta. Well, in example 2 here, we're to find the exact value of the tangent of the inverse sine of 2/3. Well, we're in the same position. Remember, an inverse sine really is an angle. And so I'm going to replace inverse sine of 2/3 by the name theta. Okay, and of course, what we know, if theta is the inverse sine of 2/3, if we take the sine of theta, we get the result of 2/3, and theta is an angle between negative pi over 2 and positive pi over 2. Now, of course, if this would have been theta is equal to inverse cosine of 2/3, then we'd have the cosine of theta is 2/3, but theta would be between 0 and pi, wouldn't it? So we've got to keep that in mind. Now, where does that leave us? Well, whoops, I got ahead of myself. Here's where that leaves us. Let's look down here. So rather than finding the tangent of inverse sine of 2/3, when we are calling it inverse sine of 2/3 by the name theta, then we're actually left with finding the value of the tangent of theta. And since tangent of theta is sine of theta over cosine of theta, and we already know the value of the sine of theta from above, sine of theta is 2/3, then for us to calculate the inverse tangent, the tangent of the inverse sine of 2/3, all we're left with doing is finding out the value of cosine of theta. And so that's what I'm doing over here, okay? I kind of got ahead of myself here, I apologize. So to find the cosine of theta, we use the identity sine squared theta plus cosine squared theta is equal to 1. And we know the value of sine of theta from over here. Sine of theta is 2/3. And so we have a 2/3 squared in this position plus cosine squared theta is equal to 1. We square 2/3, of course, and we get 4/9. And so now all I've done here is I've subtracted 4/9 from both sides of this identity. And so I have cosine squared theta is 1 subtract 4/9. And when I do this subtraction, I get 5/9. Now, here's the rest of our story, okay? Cosine squared is 5/9, so cosine of theta is either going to be plus or minus. See, theta is a specific angle that we don't know its value, but since cosine squared theta is 5/9, then cosine of theta itself is either going to be positive or it's going to be negative, and it's the square root of 5/9. Now, the way we make that determination is that we recall that our theta from above, okay, our theta from above, which is really the inverse sine, but our theta is between negative pi over 2 and positive pi over 2. And in these quadrants, the cosine will be positive, won't it? Because it's the first coordinate. So we made the determination that the cosine of theta can't be negative, it has to be positive. And it's the positive square root of 5/9. Well, that's the square root of 5 over the square root of 9, and the square root of 9, of course, is 3. So we've determined the value now of the cosine of theta being 5/3, and so we can replace it into our fraction here, put our cosine of theta in this position, and that's what I've done on this step. Okay, so now we have the tangent of the inverse sine of 2/3 is the fraction 2/3 divided by the square root of 5/3. And then we just do a little bit of arithmetic here. When we divide by a fraction, it's the same as multiplying by the reciprocal. And so that's what I've shown. Here, of course, the 3's will go out, will cancel or reduce, and so we'll be left with 2 over the square root of 5. And then it's probably best that we rationalize that by multiplying a numerator and denominator by the square root of 5. And of course, that leaves a numerator of 2 times the square root of 5 and a denominator of just 5. So this was a little more involved, and the reason it was more involved is that we had to come up with the value of cosine theta along with the other information that we already were given. Well, let's move to problem 3 now. Okay, here's what we've got in problem 3. Find the exact value of the secant of the inverse tangent of 6/7. And so we're already used to the idea of what we're going to do here, I think. We're going to be concerned about I'm sorry, I'm stammering a bit. Again, an inverse trig function is really an angle, so I'm calling the inverse tangent of 6/7 theta. Now, So now we know that the tangent of theta would be 6/7, and so theta is not one of the special angles we know, and I failed to mention that a while ago. But the inverse tangent always gives a result, that is, theta has to be between negative pi over 2 and positive pi over 2, but it can't be equal to either of those because the tangent is not defined for those values of theta. Okay, well, where does that leave us? So now what we have is, rather than saying the secant of inverse tangent is 6/7, since we're calling that inverse tangent theta, then we're actually trying to find the value of the secant of theta. Now, this becomes a big issue, okay? And I jumped ahead here by writing down, but I'm going to tell you why I'm dealing with this. Somehow or another, I need to calculate the secant of theta. And what I know is the tangent of theta. See, that's what's given to me. So my thought process is I need an identity that deals with both tangent of theta and secant of theta only. I can replace tangent of theta and then solve for secant of theta. And that identity is one of the Pythagorean identities. Tangent squared theta plus 1 is equal to secant squared theta. So from this identity, I ought to be able to find the value of the secant of theta. By doing what? Well, replacing tangent of theta with 6/7. So I have 6/7 squared plus 1 is equal to secant squared theta. And of course, here's what I'm doing. I did a couple of steps all at once here. I actually reversed the order of the equation, so I have my secant on the left side. And of course, I squared 6/7, which is 36 over 49. So secant squared theta is 36 over 49 plus 1. And of course, 1 could be written as 49 over 49. And so when I add 36 over 49 and 1, I get 85 over 49. So we have secant squared theta is equal to 85 over 49. So secant of theta itself has got to be plus or minus. Remember, theta is a specific angle, and so we're only going to get one value. It's got to be plus or minus the square root of 85 over 49. Now, which is it? Well, here's what we know. Theta is between negative pi over 2 and positive pi over 2. It can't be equal to either one of those, but it's in between. So it's in either the fourth quadrant here or the first quadrant. But since secant of theta is the same as 1 over cosine of theta, and cosine of theta is positive in these two quadrants because it's a first coordinate, then that means the secant of theta has to also be positive because it's 1 over a positive number. Okay, so for that reason, I know the secant of theta is positive, and when I look at the square root of 85 over 49, I take the square root of the numerator and divide by the square root of the denominator. And of course, the square root of 49 is 7. Well, and where does that leave us? Remember what we were trying to do? We were looking for above the secant of the inverse tangent of 6/7, and theta represents the inverse tangent of 6/7, so we were finding the secant of theta, and we just discovered that that value is the square root of 85 over 7. Well, you can see the common theme that's running through this. I'm using some kind of identity. I'm replacing the inverse trig function with an angle name and playing off of what that means. What does it mean for an angle to be equal to an inverse trig function? What can we state from that? And then finally, what we're able to do is find some identity that relates the information we have with what we're trying to find, and we go from there. Well, I'd like to look at one more example here before we move to a different topic, and let's see what that example is. Okay. Here we are to write the cosine of the inverse sine of u as an algebraic expression containing, whoops, I misspelled that, didn't I? Containing u. Pardon my misspelling right here. In other words, we're supposed to write this in a form that only contains algebraic stuff, no trigonometric functions. But we approach it just like we have been. That is, we look at this expression and we recognize inverse sine of u is really nothing more than an angle. So I'm going to call it by an angle name, and I've just done that here. Okay, so theta is inverse sine of u. That tells us that the sine of theta is equal to u, and that tells us that theta is between negative pi over 2 and positive pi over 2 inclusively. So what we need now is the cosine of theta. That's what we need to figure out. What's the cosine of theta? Well, here's where we are, okay? I know the sine of theta is u. I need to relate the sine of u and the cosine of u with an identity if I'm trying to find the cosine of u and I know the sine of u. And so that identity is the major Pythagorean theorem identity, sine squared theta plus cosine squared theta is equal to 1. Now, since sine of theta is u, this becomes u squared is equal to cosine squared theta plus cosine squared theta is 1. Subtract u squared on both sides. What am I trying to do? I'm trying to solve for cosine of theta. So subtract u squared on both sides. I end up with cosine squared theta is equal to 1 minus u squared. Now, because theta is between negative pi over 2 and pi over 2, that's right here, okay? Theta is between negative pi over 2 and positive pi over 2, then the cosine of theta is going to have to be positive. So when I'm solving, when I go from cosine squared theta, I know cosine of theta is positive square root of 1 minus u squared. Well, that's what I was looking for, wasn't it? So I can wrap this all up with my conclusion that the cosine of the inverse sine of u is the same as the cosine of theta, and the cosine of theta I've just discovered is the square root of 1 minus u squared. And this is the kind of thing that actually we do quite frequently in calculus, and we actually do this in calculus 1 quite frequently. So it's important for us to take this material seriously as we're learning now. I know we're just trying to get through this course, but it's something that we use in the future. Well, that's all I have to say about inverse trig functions. So I'm going to sign off. Good luck to you.